destroy this cell by simply cutting it up and reusing the stainless steel plates, but that's it. This portion here is going to be a little longer. This outgas comes out here, and it does push the water out of the bubbler sometimes and kind of depletes it, so this will end up dropping down longer, and then it'll go over, and then it'll go up to the bubbler sitting here, and then there'll be a longer nipple on the top which will go out to my gas output to the bubbler, and that way it'll keep a little bit larger volume of water inside this bubbler. So you got this bubbler here, and you also got the secondary hell or high water bobbler there. The other addition to this cell, which I can't put in here, as you can tell, this cell goes all the way to the top of this plate. It's not even submerged all the way in the electrolyte. I've seen on a couple other vessels blowout membranes. This is going to get a blowout membrane in it, just to make sure I don't get shrapnel all over me from acrylic flying all over, in case I get an ignition inside here. So anyway, that's it. I'm going to go ahead and probably turn it on. Here's the this is the shunt that we made a video or two back. This gives me my 1 millivolt across the positive, and it enables me to measure higher currents with my meter, which I may have destroyed the this is 20 amp. I've been running it constantly, you know, at 18, 19 amps and shooting over 20, getting my over limits. I think I finally burn out the little trace in there for the internal shunt for that. That sucks. It's unfused. This one's fused milliamp. This is unfused. Like I said, it's 20 amp. Now I don't have to worry about it. I got it millivolt now. Anyway, let's go ahead and fire this thing up for the last time, and I don't know, at least I'll have it. Alright, so what do we got? Alright, so we'll go ahead and fire this up. Here's some amperage amps right there, and I don't know if I can get the bubbler in here or not. Something like this. Here's like I said, first bubbler, second bubbler, amperage here. Let's go ahead and power on. See what happens here. Boy, oh boy, oh boy. And let's turn this a little. This foams up pretty good, I must say. This thing is just in the way. Well, lay this around here, something like that. All right, power on. And there's pulling 23 amps. Now we got outgas here from this bubbler, and we got a little bit of action over here, not a whole bunch. It's respectable. I've got so much foam in it. To me it looks like these bubbles, how this goes so deep, and I don't know how to prevent this, but it appears to me the bubbles are unable to break the surface tension of the water level, and they're just kind of being trapped in here in this heat vortex. But that's something else we're going to have to address. But anyway, there she is. Probably the last time I'm going to operate this cell. And you get a little bit of bubble action there. Yeah, like that. I like the way the test chamber came out. I'm very happy with that. I don't know if I'll even continue with this type of cylinder arrangement. I'm going to try another rectangle configuration of the cell, and I had a lot of luck with that, with the neutral cells and whatnot, and it's not going to enable me to put that in this type of body. So who knows what's going to happen to this. It may be, I don't know, I may have to retire it. We'll see how the other cell works. Anyway, that's power off right there. Amp drops pretty quick, and as you can see, it takes a bit for this active churning of the electrolyte to dissipate. But I don't know, something else we got to address, see what we can do. I got a little temperature probe on here, and lets me know the temperature of the outside of the probe, the outside of the vessel here. So anyway, that's it. So until next time, let's just see what happens.